Hi, this is Alfausia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is Operations with Complex Numbers Part 2. In our previous video, we discussed how to add and subtract a complex number set. Now we are going to discuss product and division. Let us see how to find the product of two complex numbers and how to divide two complex numbers. So these are the formulas to multiply and then divide any two complex numbers. Now let us see how to apply these rules, and also we can discuss the steps to follow in product and division. Multiplying complex numbers requires more detail than adding or subtracting complex numbers. Very similar to addition and subtraction, I am going to take some expression. Using that example, I am going to show you how to multiply complex numbers. Consider this expression. So consider how you would simplify it. You can simplify by multiplying the coefficients together and then the variables together. Am I right? So 5 times negative 3 and x times x, which will give you negative 15x square. Am I right? Same way, multiplying two imaginary but not complex numbers together works in a similar way. But there is an additional step. You have to start with the same method to multiply 5i and negative 3i. As usual, you are going to multiply the coefficients, which gives negative 15 when multiplied, and multiplying the variables. Here we have imaginary symbol I. So I is I square. This seems fine so far, but the I square can be simplified further. We all know that I is the square root. It is equal to square root of negative 1. So I square is equal to negative 1. So the final step is to simplify I square into negative 1. We are going to replace I square with negative 1. So 15 is our final answer. Now let me take a different example with different signs. Now multiply the coefficients of I together and then multiply I times I, which will give us 6I square. Replace I square with negative 1. 6 times negative 1 is negative 6. You can also notice that the product of two imaginary numbers is a real number. Am I right? We will also see this again when we multiply two complex numbers. For that, we have to use the distributive properties. Please consider this expression. This is a little more complicated when compared to previous example because two binomials are being multiplied. This means we have to use distributive property of multiplication. Also, please remember that multiplying using the FOIL method, FOIL, F-O-I-L, it means first outside, inside last. That is also an application of distributive property, right? So you can use that property to multiply. So we use this concept in algebra. Same concept we are going to use in multiplication of complex numbers. Let me take an example and explain you. Here is an example. 2 plus 3i times 1 minus 4i. To multiply these complex numbers, we are going to use a multiplication table. Doing so helps us to organize all the information in one place. We will place the first complex number along the top of the table and the left side of the table. So here is the table. Now we need to start multiplying columns times row. So we will multiply 1 times 2. So that will give you 2. Next, we are going to multiply 1 times 3i. And then next, we are going to multiply 2 times negative 4i. That will give you negative 8i. Lastly, multiply negative 4i times 3i. That will give you, multiply the coefficients first and then I. So that will give you negative 12i square. I have just multiplied everything. I am not replacing I square by negative 1 in this step. So next, let's arrange all the terms together from our table. 2 plus 3i minus 8i minus 12i square. Now we need to make a substitution for the I squared. I squared is equal to negative 1. So making the substitution, we will get. So you can clean up the expression just by multiplying these two. Negative times negative will give you positive 12. And then you can also combine the like terms. 3 minus 8 is negative 5. Same way 3i minus 8i is negative 5i. You should only add and subtract the like terms. Hope you know this rule. Okay, here 2 and this one. These are real values and these two are imaginary values. So you are able to add and subtract the real values with another real value only. Same way, you can combine only the imaginary values together. So here is the final solution for this example. 2 plus 12 is 14. 3 minus 8i is 5i. Hope you are clear with this example. Okay. Okay, now let's summarize the steps. The product of the two complex numbers is defined as this rule. A plus bi, let this be one complex number, and c plus di, let this be another complex number. So if you are multiplying these two, the rule is going to be ac minus bd plus ad plus bc times I. And I have just grouped the real numbers and imaginary numbers. So these are the three steps we should follow when multiplying two complex numbers. First, you have to use the FOIL method to find the product. FOIL means the distributive property that we generally call. And one more step is you have to replace I square by -1. This is an important step because only then you can identify the real numbers and imaginary numbers. That will help you to combine the like terms. Finally, you have to write your answer in the form of a plus bi. So it is very necessary to write your answer in the standard form. Consider a complex number a plus bi and a minus bi. The complex numbers a plus bi and a minus bi are called conjugates. They are very similar, but only the sign in between is different. So if that is the case, we call it as conjugates. The product of conjugates is the real number. Hope you are clear with this rule. I'll also show you an example. Consider these conjugates 5 plus 2y and 5 minus 2y. The product is going to be a square plus b square. So a square is 5 square. Or you can directly apply the formula a plus b times a minus b is a square minus b square. Finally we will get this because I square is equal to -1. 5 square is 25 and I square is -1. Did you notice that I have got a square plus b square now? So 25 plus 4 is 29. Yes, we have got a real number as the product of the conjugates. Hope you got an idea on the product of complex numbers. Okay, let us now see the next operation, division. Let us see how to divide two complex numbers. This fourth rule is applicable when you are going to divide any two complex numbers. Dividing complex numbers is a bit technical. To deal with it, we have to deal with something that is called conjugates, what we discussed just before. A conjugate of a complex number is gained by taking the opposite of the imaginary part of a complex number. Am I right? We know that every time we multiply complex conjugates, the imaginary term cancels and we obtain a real answer. So we can make use of this interesting phenomenon when we divide complex numbers. It is nothing but a rational expression that contains one or more complex numbers which is in simplest form when there are no imaginary numbers remaining in the denominator. Here is an example of a division problem. This same problem can be written vertically just like a fraction. So, to divide these complex numbers, we are going to employ a slight trick. The only way to clean up this division problem is to cancel the imaginary numbers in the denominator. We will do so by multiplying the denominators by its complex conjugate. Complex conjugate of 3 plus 2y is 3 minus 2y. So, I am going to multiply and divide both numerator and denominator by 3 minus 2y, the conjugate of the denominator. Here we are just going to do the fractional multiplication. Multiply the numerator with numerator, denominator with denominator. Again, you are going to use the complex number multiplication. We are going to use FOIL or distribution. So, we multiplied the numerator by the same amount so as not to alter the value of the original value. We will get, I am getting 5 plus I for the numerator and for the denominator I get 13. Hope you are getting the same answer. Okay, let's now place these expressions. So I have written everything in fraction form. Lastly, we need to divide the entire numerator by 13. I am just going to write the common denominator separately for each of the term. 5 over 13 plus 1 over 13 times I. Because we need to write our answer in the complex number format, no? A plus bi. That's the reason I have splitted the denominator, not as a common denominator. So here you have to first follow step 1. Multiply the numerator and denominator by the conjugate of the denominator. And then you have to replace I square by -1. You'll be getting I square while doing the FOIL method. And then do the fractional multiplication for numerator and denominator separately. Finally, write the answer in the form of a plus bi. So when the divisor, that is, the denominator in the fraction is a complex number with non-zero real and imaginary parts, you must rationalize the denominator using the complex conjugate. Please remember that the product of the complex number with its complex conjugate is always a real number. So the denominator will be a real number. Am I right? This means the result will be equivalent but rationalized. Hope you got an idea on both division and multiplication. In case if you get any query, kindly